Hello, everyone. Thank you for tuning into this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and we bring you discussions from creators and from innovators in various aspects of technology. And today we're going to be talking about Agentic AI. And we have with us someone from this organization called Akka. That's AKKA. That's the names of the URL is akka.io. If you want to check them out, akkka.io, that's the website to go to. And we're talking to the CEO of Akka. We have Tyler Jewell with us, and he's going to be talking about Akka's approach to agentic AI, some of the challenges that they're seeing, and just how they're innovating in this space. So that's going to be the topic for today. If you like what you're hearing, go and check out what Akka is doing, and also check out all of the other conversations we're having with all of the other startups over at our website, softwareplaza.com, or you can find us on Spotify as well with the Software Plaza podcast. All right, with that, let's get started. Tyler, it's great to have you with us. Thanks for joining.
Good day to you, Twain. Thank you for having us.
All right. So agentic AI, it's all the rage. You can't attend a conference these days and not hear the phrase agentic AI. It's really on everyone's minds these days. But we're going to get into that. But before that, just wanted to ask you a bit about yourself. Tell us about your journey up to Akka and what you've been up to and what led you to Akka.
Well, I have a pretty interesting type of background. I studied classic computer science and tried to become a software engineer in the 90s, and I wasn't very good at software engineering, and quickly pivoted into product and product management, and spent about 10 years doing product-related work on development platforms. So this was at BEA when they had the WebLogic platform, which was a Java EE-based system, and then work at Quest Software, and even a short stint at MySQL before they were acquired by Sun Microsystems. And that was a really wonderful career, and that led to actually having kind of a dual opportunity in my life. I was very good at seeing emerging trends and building and shipping technologies related to those emerging trends. And I got into a dual role as both a venture capitalist and as a founder of a startup. And I ultimately went on to run 3 different technology companies. They all got acquired. One of them was a tabloid media company for Java and .NET developers that I got acquired by TechTarget. I started a company called CodeEnvy, which was a cloud IDE. It was Replit before Replit was invented, and that was acquired by Red Hat in 2017. And I went on to invest and run a company called WSO2, which was acquired last year by EQT for about $650 million. That was an open source enterprise service bus. But along the way, I started doing a lot of research on developer experience and developer platforms. And starting in 2009, I built up a database of all the commercial products and companies and the ARR associated with them anywhere in the DevX space. And when I did a first version of that database, it was about 200 companies that were listed, or about 200 products 15 years ago. And now there's close to 1,800 in the database, and it's still maintained, and we publish it online. And that's just kind of created a lot of great opportunities to invest in developer platform businesses, and focus on really understanding what the nature of developer experience is. And in about 2019, I was doing investments on behalf of Dell, and one of the investments we did was a company called Lightbend, which is now known as Akka. We had rebranded the company, and it was just an absolutely spectacular and wonderful company. And I spent 6 years on the board, and about a year and a half, 2 years ago, the founder and I had a meeting of the minds on what the opportunity was, and I joined as its CEO for the fourth company for me to run about January of last year, and now we're here. We are we're known as Akka. We're in an enterprise agentic AI company, and have a great story to tell, and happy to be here to tell it.
Interesting. So what was Lightbend about? And by the way, just quite an illustrious career you had there with just a lot of milestones. Yeah, quite something. Lightbend. So yeah, what was Lightbend about, and how did it transition to Akka?
Yeah, so Lightbin was started in 2009 by our founder and CTO, who's still with the company. His name is Jonas Bonnet. And what Jonas had done is he had built an open source framework, developer framework, if you will, to simplify how to build concurrent systems that run on multi-core CPUs. And in 2009, that was actually a really hard problem. You had to be nearly a graduate level in computer science in order to understand all the threading, locking, and asynchronous communication principles necessary to do it without crashing the entire system. And Jonas used some 1970s computer science called actors. And actors are a form of concurrency that allow you to have effectively like a unit of processing. And you can do that unit of processing in a way with supervisors and communication between actors that is completely asynchronous and non-blocking. And when you do it correctly, you can get incredible levels of concurrency, like hundreds of millions of actors per core, with very efficient resource usage. And Akka, became an overnight sensation. And over the years, it's been downloaded almost 1.5 billion times. There's over 100,000 systems that have been built on top of Akka. And on any given day, there's like 2 billion people who touch an application that has Akka at its runtime somewhere underneath the covers on that. So it's fairly pervasive in what it does, and it's basically proven as the most efficient form of concurrency that you can do. What turns out interestingly is you think like, wow, is concurrency on multiple cores all that important? Yes, it is, but it turns out that the techniques that Jonas used to create concurrency on multiple cores are just as effective if you want to take those things and move them as microservices across the network, across time and space. And so Akka's actor concurrency model is equally effective if you're trying to distribute data around the globe, or you're trying to distribute logic around the globe. And Akka has kind of transformed itself over those years into a very rich toolkit of everything that you need to build distributed systems. And that Lightbin, the company, was a commercial entity that was trying to monetize the role of Akka, and that went through all kinds of different iterations before we've now rebranded and become Akka the company as well.
All right, all right. Wow, quite a story there. So Akka, yeah, talking about more broadly agentic AI and just the shift that's happening that we're seeing. So a lot of people are talking about it. Some actively implementing. But along with this come different challenges, and some that many may not see at the start. I just wanted to get your view as we start talking about this. What do you see happening with agentic AI? What are some of the reasons people want to adopt them? What are some of the use cases? What brings
Yeah.
people to them? And
Yeah.
even some of the the challenges, the roadblocks that they face as they start adopting agentic AI.
You're gonna love this. We can spend all day on this. So let's talk about why is agentic AI all the rage? And to be honest, I was a bit skeptical when it first came along. We as a company were fairly skeptical about it through most of 2024. And it was actually our own customers who came to us last fall and said, hey, we really are studying this agentic AI. We're using Akka in agentic systems, and Akka has a fundamental role to play here. And part of the reasons we were skeptical on it is that it seemed almost magical, and when something is magical, it creates this illusion of that it must not be legitimate or stable, or that it's all hype at the end of the day. But what turned us around, where we had our haha moment with it, was that when you realize that an LLM, a large language model, even though it's natural language, you can constrain the natural language in such a way that you can turn the LLM into a type of programming widget at the end of the day. Meaning that if you ask the LLM the right kind of question, you can get a structured response. And once you realize that you can start answering structured questions and getting structured responses, suddenly the LLM starts to look a lot like the transistor all over again. And that what you've got now is a very rich and powerful transistor. Instead of it doing like 0 and 1, it can actually do hundreds of potential answers, but it's still structured in its output at the end of the day. And so once you realize that, suddenly now what we have is, instead of the driver of innovation being programmers who can code, which is what's happened over the last 20 years, right? That's where all the innovation has come from. Now, suddenly, all the innovators can be anybody who can reason. Because if you can start writing prompts, you can now start doing the same sort of things that programmers were able to do. And so agentic AI is really the whole discipline of how do you harness these LLMs to become these powerful programmatic constructs, and to use them in a very kind of standard, dependable, safe, and reliable sort of way. And that's why it's so exciting, because every organization on the planet, if you start adopting agentic AI, you can now unlock all of your employees to be as powerful as your developers were before. And how much innovation can we create as a result of that? So that's what's really, I think that's what the hype is, and that's what got us excited by that. And that's why the industry is kind of piling into it so quickly.
Yeah, okay. So kind of sounds echoes some of the ideas of like what we heard like maybe a decade ago with like talking about citizen developers and low code, and those are probably the previous generation.
Yeah.
Uh, how would this so how would this be different from that movement where there was low code apps and connectors? What's different
Yeah.
here?
Yeah. There are low code agentic systems now as well, right? So there is, low code systems, there's low code agentic systems. And I think that the distinction really helps itself is that there's a difference between business automation
Mhm.
and intelligent automation, and then autonomy. And in business automation, what you're trying to do is you have these very structured sort of workflows. You
Yeah.
have very structured inputs, forms, if you will, or documents that you're trying to work off of. And
Hmm.
when things are that structured, there isn't a huge value to the LLM. The LLM does really well when there's unstructured information or unstructured logic. So an LLM is kind of just a different approach to robotic process automation or low code automation that you had. But instead of programming it, you can write it in natural language. You can give it a prompt, you can ask
Hmm.
it to do something, and it can follow through on it. Where this gets more interesting is when you get into intelligent automation or autonomous systems. And intelligent automation starts to happen when you have uh, uh, an unknown workflow that you need to
Yeah.
do, right? And the LLM can help you actually figure out what the workflow should be, such as, I need to do research on these
Hmm.
4 diseases, and
Hmm.
I need to come up with a plan for how I'm going to compare and contrast all of those things. It's
Yeah.
not clear how you might do that. And so the
Hmm.
LLM can actually come up with a plan to do that. So that's kind of an
Okay.
unstructured form of workflow that
Uh,
you need to do.
yeah, yeah.
And there's all kinds of variations on that with intelligent automation. Other
Hmm.
things, like if there's unstructured data, like one of our accounts, they have this huge database of messages that they process. They process like 5 billion messages a year, and they get like 500 errors of that. And the errors fail for unknown reasons. and so the error message is also unknown. And so
Okay.
that's a great association, because the LLM can look at all the messages that succeeded and then look at the messages that didn't succeed and speculate and
Okay.
hypothesize on what the root cause could be, right? So that's
Interesting.
another example of a kind of unknown unknowns. And
Mm-hmm.
then yeah, and then the last is like true autonomy, which is you really want, an agent to behave in the role of a human being,
Mm-hmm.
like a software engineer or maybe like a junior accountant, and you give them a lot of properties, teaching them like this is how you're supposed to think about something, and
Mm-hmm.
then you give it general problems, and it actually will, make recommendations against those problems, and even if you give it the authority, it can then act on the recommendations autonomously as well. And so that really applies to, replacing individuals or augmenting individuals, or even something like self-healing IT systems. So if you have a very big IT system, and it's periodically failing, let the LLM come to its own conclusion on things it should try, and it will, automate the process of self-healing, even if it doesn't get it right on that.
Wow, those are some great use cases. Are these some of the common use cases that you see even within your customers? I'm trying to get like an understanding of, what your customers use Akka for most predominantly. And so, our conversation can be around some of those use cases as well.
Yeah. Well, generally people come to Akka when the SLA matters the most. And SLA here means large volumes of agentic requests, or you need to respond back to people in a certain amount of time, or just the amount of
Mm-hmm.
data that you're processing. So Akka's always been a reputation for, very large systems that have a very precise type of SLA that has to be delivered. How does that apply to agentic systems? Well, the most common ones are, think of them as like scalable chatbots.
Mm-hmm.
I think, the chatbots were all the rage, but now when you have them kind of be intelligent LLMs, what you do is you can have them take on specialty types of interactions with people. And so
Yeah.
there's a real emphasis on people engaging either through personalization or through some sort of support customer service workflow directly with everybody on their website 100% of the time. And in that situation, you get into really high volumes. I mean, you could have potentially hundreds of thousands of interactions going on concurrently,
Mm-hmm.
and they're all backed by some sort of intelligent automation or intelligent LLM interaction with that. Other situations, personalization of data is in real time is a very big deal. So Tubi, Tubi, which is owned by Fox, is one of our customers here, and Swiggy is another one. In their particular situation, there's all sorts of kind of real time, let's call it clickstream data or analysis data on the users and what they're doing on their sites at any given moment,
Mm-hmm.
and you want to personalize either content or advertising or whatever it may be based upon their behavior. And in order to do that, you have to collect all that information in real time. You have to aggregate it in real time without overloading the system, because it doesn't stop. It comes in continuously. And then you still need to periodically send it to a model, and the model will do the sort of conclusive work to make recommendations on that. And then you got to pass those recommendations along, and this becomes a kind of a continuous feedback loop. So those sort of systems are very, very powerful, because you're blending the intelligence of the model's recommendations with kind of the real-time activity that's happening. And customers want to get that feedback to their user in under like a second. They don't want to wait 10 or 30 seconds for that work to be done. They want that loop to be milliseconds on that interaction. So that's also, a pretty common sort of thing. And then because we're so performant and lightweight, we get a lot of edge and IoT use cases. And there's agentic AI on the edge as well, such as
Mm-hmm.
the edge is really predominantly made of all kinds of different devices that are giving off like high-speed vehicle telemetry or medical device sensor readings, whatever that may be. And you want to do analysis and recommendations off that data without it making its way all the way to the cloud. So analysis and recommendations on the edge requires model execution and inference right there next to the metrics. So that's pretty
Mm-hmm.
common case for us too.
All right. Yeah. Wow, there's some really cool use cases. And it's great to hear that because, you guys are at the front lines and agentic AI is so new. So really, you're getting like a front row seat to like witness this transformation. I'm just curious, even within these organizations, do you see who owns these functions? Like who sets these up? Are organizations putting out, dedicated agentic AI teams already, or is that still some time away? Are
Yeah. Yeah,
depart
it's
yeah.
absolutely a spectacular question, and right now it's coming from I see it kind of coming from three types of directions on it.
Hmm.
The more traditional direction is that there's some sort of chief AI officer or data like a chief data officer, which has already had long-term responsibility for machine learning and ML ops capabilities.
Hmm.
And those teams are starting to graduate into saying, oh, we're now going to be the agentic team as well.
Hmm.
That's hit and miss. That's hit and miss because what you're doing is you're taking teams that are professional data engineers and asking them to become distributed systems experts, right? So that is an interesting dynamic. The
Hmm.
second dimension that happens is you get a lot of organizations who have gotten religion that agentic AI is going to be this innovation engine.
Yeah.
And the innovation engine needs to come out of IT. So the CIO has then some sort of charter or mandate. And it's either, hey, we figure out all the ways to leverage this stuff so that we can be an innovation engine. So that's the CIO who drives that. Or
Hmm.
it's the data science team has realized like, hey, we've gone as far as we can. We're now done experimenting, and we're handing it off to you to productize it, if you will, to IT on that. So that's the
Hmm.
second dimension. And then the third
Hmm.
dimension is just, I guess we could call it shadow agentic, but it's
Okay.
really that it's an organization where they've said we see the light, we know that AI is super critical, and everybody
Hmm.
in the company is just kind of expected to figure out how to
Uh,
incorporate it. So there's no real like executive owner, but everybody knows that it's important and they're all kind of, diving in and figuring things out.
Wow, really interesting. What's your take on these approaches? Do you think all three are legitimate and have their place in some organizations? Maybe some are more suited to one than the other, or do you think there's one that really stands out that is
Uh,
recommended?
You know, we think that the IT driven approach is probably the safest approach for
Okay.
organizations to drive towards, and we can give some reasons on that. But I think the thing that I'll underscore is that Gartner says 60% of agentic projects never make it to production, or that they
Mhm.
fail, right? And I think it's arguably much higher than that at the end of the day. And there's a bunch of reasons for that. It's safety issues with the LLM. There's reliability issues because it's a non-deterministic and stochastic engine.
Mhm.
There's lack of experience just from the teams that are out there. So there's all sorts of reasons for that. And what you realize is that agentic systems are distributed systems, meaning that you have to, the whole point of a distributed system is to try to provide reliability against an unreliable environment.
Mhm.
In generally distributed systems, we're dealing with network disruptions or hardware failures or whatever that may be. But the LLM is a type of disruption. There's a form of uncertainty in that. And so I think IT makes the most sense for being the long-term owners of these systems because IT has had a history of defining SLAs and then managing very consistently against SLAs. That's the whole business model for an IT shop. And
Mhm.
and and the SLA gets more complicated with an agentic because of accuracy and safety issues, but it's
Mhm.
still an SLA. And so the IT organization, even though they're maybe not data scientists and reasoning specialists, they're the organizations that's best suited to long-term viability of these systems.
Interesting. Interesting. So that is the most reliable, the safest route to take for adoption. You mentioned about some of the challenges, and I wanted to dig into that next. So, what are some of the challenges with adopting AI? You mentioned security, you mentioned accuracy, you mentioned reliability in your last response. You hinted at these challenges, but define it for us more clearly. Call it out and tell us what are the top
Yeah.
challenges that you see organizations facing.
Yeah, I mean the meta challenge is that your job is to try to create certainty using highly unreliable LLMs. Right, that's the meta challenge with these things. That sounds simple enough, but there's all kinds of dimensions to it. Because they're unreliable, accuracy and safety are really hard problems that have to be tackled. Because agentic systems are also distributed systems, reliability is really a challenge. Like, how do you get a system that never goes down, that can recover from any type of failure? That's a distributed systems problem. So that's elasticity and resilience that you have to deal with. But maybe the biggest challenges that people have not yet become aware of are cost and the developer experience. And the cost issue is severe. If you take a 1000 TPS system, a TPS means transactions per second, right? A 1K TPS system that was just a basic database system of the last 20 years, right? That cost you maybe $1,000, a month, to at max to operate something like that with infrastructure and everything that you got to pay for at a cloud provider. But with a agentic system, with all the components that it needs and the way that those components need to operate, it gets upwards of $10,000 a month just for the compute and infrastructure that you need to run that. So there's a cost problem there, but then the cost problem is amplified even further, in that if you do a 1K TPS system that every transaction interacts with an LLM for some reasoning agent, your token costs are going to be anywhere from 20 cents to $20 a second. And 20 cents to $20 a second grows up to $500,000 to, $600 million a year, right? So the first thing you got to do is you got to have a system that gets those token and infrastructure costs under control. And right now, there's all sorts of rage. There's all sorts of great little programming languages that let you build agents quickly. They'll let you build the agent quickly, but they do nothing to manage your costs. And the moment you put this sort of in production and you've got recurring execution, the cost management becomes a real big problem. The second is the developer experience. The developer experience is a super problem, and that there's a lot of frameworks out there that give you a really simple way to build an agent, but an agent is not the entire ecosystem. The agent has to have coordination by an orchestrator for multiple agents over a long running time frame. There's all kinds of different forms of memory, which is forms of persistence that you need to have. And then if you want the system to evolve, you got to have continuous process and streaming as part of that. And so historically, those have been 4 different developer experiences, 4 different frameworks that you've got to do, and 4 different skill sets that the agentic developers have to figure out. We're super proud at Akka, because the whole point of Akka with our concurrency model is we can reduce your token cost by up to 10%, and we can reduce your infrastructure cost by 90%, given the way we handle distributed systems. And Akka gives you a single DevX for all 4 of those things, and so we can build entire agentic systems in minutes that are production grade with it. So our focus has been solving those 2 problems.
Very interesting. Yeah, you should definitely get into the details a bit more about how you managed to save these costs in just a bit. But yeah, quite interesting that you brought up those challenges, which I guess it's still early days, and so no one's probably not as many have scaled and really pushed the limits of agentic AI. So probably someone's getting started, they're thinking about security, thinking about accuracy, but then I'm sure that these 2 challenges that you just mentioned, cost and the developer experience, are coming up. So really interesting that you brought that up there. So yeah, so wanted to just talk about some of the design patterns. Saw some of your writing on your website, on your blog as well, and you talk about AI agentic design patterns. And so some of them are like there's COT, there's reflective agents, there's MCP, A2A, a bunch of these, acronyms and just different
Yeah.
patterns.
Yeah.
What are these design patterns? Talk about some of them and how they're good. Some of them that may not be as helpful. What are your views
Yeah.
on each of these design patterns?
Well, let's first establish that the agentic industry is very young, right?
Mhm.
And it's young enough where there are emerging patterns, but let's call them emerging patterns, and it's still way too early to know what is considered a best practice pattern or not. Yeah.
Okay.
Um, and really what patterns reflect is how do you use multiple agents in some sort of coordinated dance? And
Mhm.
how do you kind of get them to work together in a cooperative or collaborative mode to work towards a common goal on that? And
Mhm.
um, uh, because you can ask an agent to analyze something and then get a response, uh, agentic patterns are basically just techniques of having multiple agents with kind of given different tasks or different expectations. And then you kind of coordinate their responses in a way toward, working towards kind of the final sort of outcome on that. So this
Mhm.
the sort of so the simplest sort of example that you can do for that is, let's say you have a problem where there's many different possible solutions, and what you do is you just give that problem to three different agents, ask them to each come up with an answer, maybe with a slightly different perspective or a slightly different tone or whatever that may be, and then you take all the results and you give it to a fourth agent who comes up with analyzes the results and then says, what is the consensus on that?
Mhm.
Right. So it's just kind of almost like a voting mechanism, if you will, on that. And so it's all that is four different agents. Three of the agents run in parallel. The fourth one gets all the inputs or I'm sorry, the outputs from the first three, and then but it has a different job. Its job is to kind of come up with a consensus mechanism based upon what they read. And that is a whole pattern right there, right? And that's a reproducible sort of pattern that you can use for democratic analysis purposes. Another type of pattern is a document processing flows. So we had a client who built a 16 agent system. They did it with two developers over 2 months, and they're processing petabytes of data. And what they wanted to do is uh, they wanted to help doctors and patients analyze all the emerging medical treatments, because there's just too many innovations that are happening for people to be able to read and understand it all. And so they created this pipeline where they have a few agents that are just sourcing all the medical research around the planet and dissecting that and decomposing that into basically categories of information. And then they've got other agents that they've trained as specialists for different medical domains that can then analyze that and then synthesize it down. And then there are agents that can actually do recommendations off of that, recommendations specific to doctors or recommendations specific to patients on that. And so that's kind of a structured pipeline of a handoff of things that they do. And there's no consistency on how these patterns exist or the names associated with them. But there's probably a 10 or so that exist out there that you can use and put behind some sort of workflow and get some sort of specialized output associated with it. Um,
Quite interesting.
yeah.
Yeah.
The well, all I'll say is that the challenges here aren't in figuring out the pattern or even setting up the workflow. The challenges are, how do you do the context engineering of making sure that each agent has the right prompt and the right goal and the right data. That's where the hard work is, right?
Mhm. Mhm.
And fine-tuning that to a
Yeah.
reasonable,
Yeah.
you know.
Yeah, I can imagine. I mean, with that many agents for each workflow, and then, if you have multiple workflows and each having multiple agents, it can really scale and become quite messy after a while. And, not to mention cost, which is what you spoke about just earlier, that's the big challenge. So I can see, how these costs can really spike if you have multiple agents on single workflows itself.
Yeah.
Uh, yeah, really interesting. So I want to get into talking about Akka's approach. And you have for us an architecture diagram, so you could walk us through even, that in your response. But yeah, just get us started with Akka's approach to, build agentic AI infrastructure, and
Yeah,
then, explain it with your architecture diagram.
sure. Yeah, so Akka is a development platform for both building and running your agentic services.
Mhm,
And we take a system-wide approach, meaning that we provide everything that you need to build, test, and run the agentic services. And so that includes four things. It's
mhm,
it's orchestration, so workflow, so you can build workflows to manage long-running processes across multiple agents. It's
mhm,
an agentic development platform so that you can build agents that work with any kind of different number of models, uh, with any sort of logic and knowledge that it's integrated in. That also
mhm,
includes APIs so that you can expose these agents through web services over the internet. The
mhm,
third thing is that it includes memory. This is both short-term and long-term memory, and memory is a way to capture all the interactions between agents and users, or agents and their tools, or agents and their LLMs. And memory is implicit with us. It's just automatically included. It's kind of fundamental to how Akka works, so that the memory
mhm,
is sharded and distributed around the world. And then
mhm,
there's also stream processing as well, so that you can take real-time data feeds like we talked about with Tubi, and then based upon those real-time data feeds, whether it's audio, video, metrics, whatever that is, you can then modify the agent's behavior or its memory in some sort of adaptive loop. And all of that is part of a common SDK. So you write these systems in a declarative sort of syntax. It's very easy to do. And then when you build these things, Akka builds them, and then they're capable of running on any infrastructure that you want. You can run this on Kubernetes or on Docker Compose, on VMs, Edge, wherever that is. And it doesn't require any other infrastructure to be installed. So Akka provides effectively all of the runtime capabilities inside the binary that it builds for you. And when you run these things, you can basically build up Akka clusters. We have customers who run millions of nodes of Akka clusters, and those Akka clusters take responsibility for elasticity, resilience, upgrades, updates. So there's all sorts of kind of properties, if you will, distributed systems properties that are just inherent inside the Akka cluster. And you
mhm,
can deploy these clusters, as many of these clusters as you want. And then there's kind of zero trust communication mechanisms between services in the clusters. And then we take this even further in that you can run clusters across different regions around the world, and we can do replication, failover, and disaster recovery on different regions as well. And the
mhm,
combination of all these sort of things get ultra low millisecond latencies for reads and writes. You get 6 nines of availability for the services that you have. You also get ultra low RPO and RTO objectives with this. And this is all self-managing. This is entirely self-managing. Akka handles all of this stuff. We even really proud, because if it builds and runs and tests validly on your local developer desktop, then it's ready for this sort of production mass scale.
mhm, mhm. Wow, really interesting. And what are some of the requirements? What are the base requirements at all for running Akka?
Oh, you base requirements for running Akka, couple of megabytes around. You can do a really small instance, a single node instance, and it goes from there. We have customers who the overhead of Akka is very, very low at the end of the day.
Okay.
It is a JVM based runtime, but the JVM is what allows us to do that high level of concurrency that we talked about. And what's interesting is that when we compare ourselves to Python runtimes, we can get 80% more dense execution. And the way to think about that is, for one core of Akka that you've deployed, you would need 4 to 5 cores for the same system built with Python on that. And so that equates to about $1,400 a year just in cloud cost savings, like the cores that you're not having to purchase at an infrastructure level. And then also because of the way everything's non-blocking and event-driven in Akka's runtime, we can actually reduce your token counts by up to 10%. And we're able to do this because we can interrupt long-running LLMs that are wasting tokens on you. And so the combination of higher concurrency and reduced token consumption leads to significant cost savings and ultimately our value proposition that we sell against.
Interesting, interesting. Wow. So your architecture diagram here, would you like to walk us through it, some of the key parts there that we may not notice that you can call out?
Yeah, I mean, if you look at right in the heart of it here, we've got some Akka clusters that you can build, and you can build and run as many of these as you want. And there's no dependencies. The only dependency for running that cluster is a JVM. That's it. Uh, Now, how does it get into that cluster? Now, deployment is in a registry. So there's you build your image, you pack it, and so you can do it as a Docker image or whatever other type of binary, and that goes through a registry. And all that information comes from the far left here, where you're just writing code in a structured sort of project approach. And we have an AI-assisted DevX. There's actually this great demo you can go and see. We can actually, through Claude Code or Junie or Devin AI, whatever it is, we've built up this sort of kind of super intelligence mechanism. And we did a live demo last week where we built an entire multi-agent system. It had an MCP server, it had an endpoint, it had unit tests, and we deployed it as a 3-node cluster with failover. We did all that without writing a single line of code. We only gave prompts to Claude, and it got it right 100% of the time without any hallucinations. And it took us about 20 minutes, and we built the whole system and then deployed it into production. And it had memory. It didn't have stream processing, but it had everything else going on associated with it, right? It's really quite stunning. So you could rapidly build these systems. And then obviously, your agents are going to depend upon external MCP servers or commercial LLMs or some sort of self-hosted model environment. If you have audio, video, or event-driven metrics like Kafka brokers, those feed in to the stream processing, so you can source those and then act on that. And then ultimately, if you want to go to multiple regions, you can run multiple regions of Akka, and we automate the replication of your memory between those regions in an active-active scenario. And that's the root of like multi-region failover and multi-region disaster recovery as well.
All right, all right. Wow, really neat. What's the name of that video? Is it on YouTube? Like, how do people?
Yeah, if you want to see the live demo of it, we've got a bunch of demos on our website, but the live demo itself is in a webinar. If you just go to our blog, there's a blog post there, like "Certainty in the Face of Uncertainty" is, I think, the title of it. And it was a week ago today, so it'd be like July 17th that we did it. And if you just watch it, the first 15 minutes is me pontificating, but then the last 20 minutes is just this live demo, and it's really stunning. And what's wild is, the fact that we can do all that without writing any lines of code. I think it's a real testament to our engineers in that our competitors, like which are Python based, haven't been able to get to that level of autonomy yet. And the reason being that we can get there and they haven't is that the Akka SDK has been designed carefully over 8 years. And it's designed to be heavily opinionated and with a very small surface area, so that it's based upon our 15 years of distributed systems research. But because each of the components that you can use to build systems have a small surface area, there's no leaky abstractions anywhere in that. And we've kind of used this in anger for such a long period of time that there's only one way to use these components. And since there's only one way, it's very difficult for the LLMs to hallucinate when you tell them to make use of these things to create like an agent or to edit it or modify it. Because since there's only one way to do things, it gets it right each and every time. And so then it basically provides all kinds of amazing developer experience with the AI assistance tools that you can do with that.
All right, cool. That's awesome. We're winding down. I saw though that you had a new release recently, I think in July 14, around the 14th. What's new in this release? Anything major that you'd like to mention?
I think that was the release where we introduced actually an agent component for the first time. So it was you can build as opposed to deriving them from other components, it was a core agent component. And then also with that, we introduced what we call implicit memory, so that you get the memory for free inside of your agents. You get the memory for free inside your workflows. There's nothing that a developer has to do to program that. And we also introduced what was kind of our inline evaluation and intelligence, which is what enables us to reduce your token counts, because we can make all these sort of interrupt decisions as the processing is going on that save on the token cost. And even a 5% reduction in token costs can save you millions of dollars a year. So that was a big deal.
Okay. Wow. Yeah, that's quite a few major features that you released there. Last question for you, Tyler, is just as you look ahead the next year or so, what are you keeping an eye on? What do you see as the next stage of evolution in this story of agentic AI? What are you reading on Reddit, on any of the forums or the news articles that you read? What's on your mind?
I think that kind of the dream is that you can create an agentic system that has a feedback loop and micro reinforcement learning that continuously improves itself without human involvement in that anymore. It's possible to do those sort of systems today, but they're very either performance inhibitive or cost prohibitive on it.
Hmm?
Meaning that the feedback loops takes too long to incorporate such that it doesn't get you enough benefits on that. And I don't think we're far off from being able to compartmentalize each interaction into something where after each interaction that a user has with that agent, the system can adapt and evolve itself automatically to be just a little bit better the next time around, and then to do that continuously, even with millions of users hitting it at per second. I think that something like that, if we get to that sort of level, that's going to be kind of a game changer for the industry.
Yeah, yeah. But it's moving so fast, the pace of AI and agentic AI, but yeah, a year from now, it's going to be quite different. And we definitely want to have you back pretty soon to talk about all that's happened in the next few months. So do come back. We love talking to you about the all the best with all that you're building with Akka.
Well, I appreciate that. It was really nice to have you have me here today, and thank you.
All right. And to all of our listeners and viewers, thanks for tuning in. We hope you enjoyed this conversation with Tyler from Akka. If you got excited just listening to what Tyler was talking about, go and check out what they're building at akka.io. That's the website. That's akka.io. So if agentic AI has been on your mind, then you definitely want to see what they're up to. If costs and the developer experience is something that matters to you, go and check out Akka. That's it for today, and we hope you'll tune in for the next episode. We'll see you on that one.